Welcome, Week 10, Chapter 9, Big Data, Cloud Computing, Location, Analytics, Concept, Tools. Going to learn what big data is how it's changing analytics, understand the motivation for business drivers and big data, become familiar with a wide range. So this is what we're going to be covering. Big data means many different things to many different people. It's not new. It's not a new fad. It has become part of business priority. It does have some challenges. Big data and analytics instigate new ways of transforming processes, organizations, entire industries, even society altogether. So let's take a look at big data. Let's look at our vignette. Opening example. Analyze customer churn to telecom companies using big data. Churn is the turning over of customers. When someone leaves, someone comes, that's called churn. Telecom name. Wanted to stem the tide of customer churning from its telecom services. Customer churn in telecommunications is very common. Pretty much the field is saturated, so it's companies stealing from each other. So the manager of a company realized the cancellations involved communications between customer service department and the customer. So what big data did we have? Whenever a customer had a problem about an issue, such as their bill, plan, and call quality, they would contact customer service multiple ways. These included a call center, company website, physical service walk-ins. Customers could cancel an account through one of these listed interactions. A company wanted to see if analyzing these customer interactions could yield any insight about the questions the customers asked or the contact channel they used before canceling their account. The data generated because these interactions were both text and audio, so they have to figure it out. So some of the issues they were having: data from multiple sources, data volume, solution, unified the big data, a schematic based on each data. 3 tables were created. An ID, whether it's channel, date, time, and all this information was gathered, coded, and put into the thing to see if there was cancellations that were happening. So it wasn't just collecting the data, it was involved figuring out why the people were leaving. Routes that would lead to cancellations. The company determined thousands of routes that the customer may take. The cancel service followed up. It was a provided identity, the most frequent route, canceling requests. This is the golden path. The top 20 most occurring paths led to the cancellations identified in both short and long term. So we're able to look at it through the area is either canceled. The call center or the store were the 2 areas where they would call and be canceled. Hey, what is big data? Using data to understand customer, client, and business operations, sustain, foster growth, and profitability is increasingly challenging task for today's enterprise. As more and more data becomes available in various forms and fashions, using data to understand. As more and more data becomes available in various forms, timely processing of data with traditional means becomes practicable. Big data means different things to different people. Traditionally, the term big data is used of massive volumes of data analyzed by huge organizations like Google, NASA, Amazon, point more about finding new value in what's there, pushing boundaries. Big data has been a popular term Where does big data come from? Everywhere. Google searches, your phone, your car, Internet of Things. Big data comes from everywhere we can possibly think of. Internet search indexes, detailed call records, astronomy, biology, nursing. Big data is not new. What's new is that we call it now big data. Companies have been storing huge amounts of data in data warehouses since the 1990s. Big data warehouses now in exabytes, and growth of data volumes to escalate as organizations seek to store and analyze greater levels of transactional. Many academic analysts think big data is a misnomer. What it says and what it means is not exactly. Big data is not just big. Just sheer volume of data is only one of the other things, including variety, velocity, veracity, variability, and value. The V's that define big data. Volume. Volume is obviously the most common trait of big data. Many factors contribute to the exponential increase in data volume, such as transactions-based data stored through your years of text, data constantly streaming in from social media, increasing amounts of sensors, data is collected, RFID, GPS, and so on. Variety. Data today comes in all formats, ranging from traditional database hierarchy to databases to online analyzed processing systems to text, emails, XML, sensors, videos, audio, stalker ticks, and so on. 80 to 85% of all organizations' data are in some sort of unstructured or semi-structured value. Velocity. Velocity means how fast the data is being produced. The data must be processed, captured, stored, and analyzed to meet the needs of the man. RFID tags, automated sensors, GPS settings, and smart meters are driving an increased need through. Veracity, coined by IBM. It refers to conformity of facts, accuracy, quality, truthfulness, and trustworthiness of the data. Variability. Increased data flows can be highly inconsistent with periodic peaks. That is something big trend in social media. Value proposition. Because big data is still a matter of ongoing discussion in academic and industrial circles, it's likely that more characteristics are more to be added, regardless of what happens. So if you look at the diagram on the right, on the left is everything that's being captured, how's it come, and then we get the output. It all ends up in a warehouse as we start looking at our data. Over here we have the kilobytes. As we said, we're up to exabytes, and we're just going to keep growing as we continue. I remember when terabytes were huge, but we're up past peta, and we're up to zettabytes, as you can see. Fundamentals of big data analytics. Big data by itself, regardless of the size, type, or speed, is worthless unless business users do something with to deliver the value to their organization. That's where big analytics comes into the picture. Although organizations have always run reports and dashboards against data warehouses, most have not opened these repositories in depth or on demand. This is partly because analysis tools are too complex for the average users. With the value proposition, big data brought about big changes for organization. The traditional means of capturing, storing, and analyzing data are not capable of dealing with big data effectively. Therefore, new breeds of technology. Before making it what we have, you can't process the data. Clear, keys to success: clear business needs, strong commitment to sponsorship. Clear business needs. Business investments ought to be made for the good of the business, not for the sake of the mere technology. Strong commitment to sponsorship. It is a well-known fact that if you don't have a strong commitment to executive sponsorship, it's difficult to succeed. Alignment between the business and strategy. It's essential to make sure that your analytics work is always supporting the business strategy. Facts-based decision-making culture. Fact-based decision-making culture, the number rather than institution gut feeling. Recognize that some people can't or won't adjust. Be vocal supporter. A strong infrastructure. Data warehouse provides data and an infrastructure, so we need to make sure we have a strong infrastructure. In-memory analytics solves complex near real time, and database analytics speeds time to insights, enable better data. Grid computing promotes efficiency, low cost, and appliances. Data volume, the ability to capture, store, and process huge volumes of data. Data integration, the ability to combine data that is similar to the structure. Process capability, the ability to process data quickly and capture as data convergence. Ability to keep up with security, privacy, and ownership. Skills. Big data is being harnessed, new tools must be developed. Solution cost, because big data has opened the world to possibilities, this is what we need. Problems addressed by big data analytics. The top business problems addressed by big data overall and process efficiency are cost reduction as well as enhancing customer experience. But different priorities emerge when it looked at by the industry. Process efficiency and cost reduction are perhaps among the top-ranked problems that can be addressed with big data analytics for manufacturing, government, energy, and utilities, communications and media, transport, and health sectors. Enhance customer experience. Some of the different things we need to do. Big data technology. There are a number of technology for processing and analyzing big data, but most have some common characteristics, namely to take advantage of commodity hardware to enable scale-out and parallel processing techniques. A few to name. MapReduce is a technique popularized by Google that distributes the processing of very large multi-structured data files across large cluster of machines, high performance, and achieved by breaking processes. The key point to note is a programming model, not a programming language, that is designed to be used by programmers rather than business users. The easiest way to describe how MapReduce works is through the use of an example. The input of the MapReduce, a set of color-coded squares. MapReduce system first reads the input file and splits it into multiple slices, and examples are split twice. These splits are then processed by multiple mapping programs running parallel on the node of clusters. The role of each map program is, in this case, is a group of data in split colors, the MapReduce system. Why use MapReduce? MapReduce aids organizations in processing and analyzing large volumes of multi-structured data. Applications examples allow us. Procedural nature, MapReduce makes it easy understood by skilled programmers. Also has to take advantage that developers have that. Hadoop. Hadoop is an open source framework for processing, storing, and analyzing massive amount of distributed unstructured data. Originally created by Yahoo, Hadoop was inspired by MapReduce, a user-defined function developed by Google in the early 2000s. Indexing the web, it was designed to handle petabytes and exabytes of the distributed over large portals. Hadoop clusters or runs. Hadoop's a client-based accesses unstructured and semi-structured data source, including log files, social media feeds, and so on. It breaks the data into parts, which are then loaded into a file system made up of multiple nodes running this. Hadoop distributed files. Pros and cons. The main benefit of Hadoop is that it allows enterprises to process and analyze large volumes of unstructured and semi-structured data, heretofore inaccessible to them, in a cost and time-effective manner. Because Hadoop clusters can scale to petabytes and even exabytes of data, enterprise no longer must rely on a sample of data sets, but can be processed. Downside of Hadoop Myriad components is that immature and still developing. NoSQL has emerged. Like Hadoop, processes large volumes of multi-structured data. However, whereas Hadoop is adept at supporting large scales of batch, NoSQL databases are aimed, for the most part, at serving a discrete data stored among large volumes of multi-structured data to end users. In many cases, NoSQL and Hadoop work in conjunction. The After H database for a popular NoSQL database model after the Google Big Data. Big data warehousing. There's no doubt the emergence of big data has changed and will continue to change data warehousing in a significant way. Until recently, enterprise data warehouses were centerpiece of decision support technology. Now they have to share the spotlight with the newcomer big data. The question that is popping up everywhere is whether big data is enabling technology such as Hadoop to replace data warehousing. The core of the RDMS are witness data warehouses that. The last decade or so, it's significant improvement in the area of computer-based thing, and the size is constantly increasing. Cases for Hadoop. As we covered earlier in the chapter, Hadoop is a result of new development in computer and storage grid technologies. Hadoop is a repository and refinery for our data. Hadoop is a powerful economic and active tool. After 30 years of data warehousing, data warehouse performance integral part. Data warehouse performance by indexing found to be open source databases such as MySQL and more. However,
5 minutes. 5 minutes.
enter data that provides business value. And as we can see by the table, how each one works and the advantages that it provides for us. Coexistence of Hadoop and data warehouse. There are several possible scenarios under which using a combination of Hadoop and relational database will work. In-memory analytics and Apache Spark. Hadoop utilizes a batch processing framework that lacks real-time processing capabilities. And the evolution of big data computing and memory analytics, its emerging process techniques. In-memory analytics have applications where low latency execution is required and can help build real-time dashboards for better insight and faster decision making. Popular tool Apache Spark is unified by that. Apache Spark works master-slave framework. There's a driver program that talks to the master node, also is a cluster manager, which manages the work node. Entry point. It acts as a bridge of communication and Sparks. Big data stream analytics. Along with volume and variety, as we've seen earlier, big data is velocity, which refers to the speed at which the data is created and streamed into the analytics environment. Organizations are looking for new means to process streaming data as it comes to react quickly and accurately to problems, an opportunity to please their customers again and again. Presumption is that modern day businesses are currently living by that. It's important, critical to record every piece of data because it might contain something valuable. Stream analytics is used in extracting actionable information from continuous flowing streaming data. Stream is defined as continuous flowing. The elements in the stream are often called tuples. However, in context of the semi-structured or unstructured data, the tuple is abstraction that represents a package of data. Stream analytics, perpetual analytics. Perpetual analytics, on the other hand, evaluates every incoming observation against all prior observation where there's no window size, recognizing how the new observation relates to all the other. Both streaming and perpetual analytics have their pros and cons. Critical event is a method of capturing, tracking, analyzing streams of data to detect a certain type of worthy of effect complex events, processing and an application of a stream analytics that combine data for multiple sources. Data stream mining enables technology for stream analytics is the process of extracting novel patterns. Traditional data methods required. E-commerce. Companies like Amazon, eBay are trying to make the most out of the data that they collect. Telecommunications. Big data vendors and platforms. Big data vendor landscapes is developed very wide. As in the case of many emerging technologies, even the terms change. Big data. One way to study big data is if we look at Chapter 7. Infrastructure service providers. Analytic infrastructure service providers were initially developed by two companies coming out initial between Yahoo and Facebook. A number of vendors have developed their own Hadoop distributions based on Apache open source distribution, but various levels. Two market leaders were Cloudera and Hortonworks. Cloudera was started by big data experts, including Hadoop created there. Some other areas of big data: Amazon Web Services, Microsoft Azure, Google Cloud, and IBM Cloud. Analytics service providers. The analytic layer of big data is experiencing significant development. Not surprisingly, all major traditional analytics and data services providers have incorporated big data analytics capabilities into the offering. For example, Dell, IBM, Microsoft Analytics, Oracle, and so on. And so there are many that are here. Further noted platforms. Business intelligence providers incorporating big data. In this group, we note several of the major BI software providers who, again, not surprising, have incorporated big data, SAS, MicroStrategies, and their peers. Cloud computing and business analytics is emerging technology, trends, and business analytics users should be aware of. Cloud computing. NISTA defines cloud computing a model for enabling convenient, on-demand network access to be shared, pool configuring software resources. Cloud computing style of computing is dynamically scalable over virtual resources provided over the internet. Users need not have knowledge of it or experience, but understand. Though we don't typically look at web-based email as an example of cloud computing, it's considered a basic cloud application. Typically, email applications store data and software. Practice of cloud computing is Amazon.com web services. Amazon has developed impressive technology infrastructure for e-commerce as well as BI, customers relationship, and supply chain. It has built major data centers to manage its operation. However, through Amazon Cloud Services, many other companies can employ the same facilities that they have. We have data as a service. This concept service basically advocates where data lives, the actual platform data resides doesn't matter. Data can reside in a local computer or a server. Software as a service. This model, consumers use application software run at a distance computer. Platform as a service, using this. Infrastructure as a service, same thing as network storage, and everything is thing. Location-based analytics organizations. Many examples of organizations employ analytic techniques that we have. Classifications. We first review the application that might use static location data that is called geospatial data. We then examine the explosive growth of applications that take advantage of all application data being generated today. These sections first focus on analytics applications that are being developed, and as we can look at it. Geospatial analytics, consolidated view of the overall performance. The information may include current and forecasted values, KPIs, and looking at what's going on, where they are physically located. Geographic information systems. These are used to capture, store, analyze, and manage data links to the location where the integrated sensor technology global positioning is. By integrating information about the location with the other critical business data, it allows us to have that. All right, we covered what big data is. Things people do if they exceeds the three V's: volume, veracity, and variety. MapReduce is a technique to distribute the process. Hadoop is one of the open source codes to processing data. NoSQL is another one. Cloud computing has been taking off. Cloud computing allows us to look at everything real time. Location does not matter. These are some of the different areas we can look at. Some of our homework this week, we're going to be working on Chapter 9. Your assignment is questions 1 through 5, exercise 13. Remember, it's APA format. It's in a paper style. And your discussion question. Thank you.